So you have a repair job and it's structural in nature and you really want to know what it was originally made of so you can renew it as original. You know, you've tried contacting the boat manufacturers, you've tried looking online, doing your due diligence, and you just can't find out some solid information on what was actually put in there originally. Well, one thing you can do is you can take a coupon, basically cut a little piece out of somewhere on the boat, whether it be maybe a through hole that's going to be going in, or it could be a part of the damage that's still intact that you can still kind of recover out of there. And it doesn't have to be this big, it can be smaller. And basically when you look at a composite structure, whether it be fiberglass or carbon or whatnot, you have layers of reinforcement in here running, you know, longitudinally, transversely, whatever, to give it that structural strength. Those fibers are locked in place with a resin. The fibers themselves are not combustible, but the resin is. So if we put this in a clamp and we burn it and take a torch to it, after that's all burnt out, just like an arson investigation, we should be able to come back and sort through our layers and see what we have, which will give us a greater idea of what we're dealing with. But the first thing we want to do before we do any of that is we want to take a thickness measurement of our sample. So here I have a thickness gauge here, and this one here is coming out, and you want to check it in a couple places because, you know, the glass is, you know, thicker in some places just because of resin thickness, but just kind of get an overall average if you can. And what this one here is coming out, this is coming out at 0.059. So what does that mean? 0.059 is our final thickness when laid up. So what we can do is when we're done and we figure out that this piece has laminate going this way or that way or whatnot, we can compare it to a spec sheet and see what the final thickness was on a laminate for that sample. So we'll go through it here in a minute, and but let's get to burning. All right, so here we have our piece all clamped up. We're gonna go ahead and light it up with our torch. And of course, stay upwind. You don't want to breathe this stuff. And as you can see, you'll see the layers start to peel apart as the combustible resin burns out. And if you're from North America, you know, they call this fiber reinforced plastic, and if you're from Europe, it's GRP, glass reinforced plastic. So the glass is in there, we're just burning the plastic out. So we'll let this burn out for a little bit and then we'll come back and take a closer peek at it. So our sample's all cooled down now, and you can see from this side we have some strands that are running in the 0 degree orientation. And then you can see on the back here we have some that's material that's just kind of flaking off a little bit. See if I can get my lighting right here. There you go. So you see, we'll take the toothbrush here and we'll just slowly brush this off. Now if you see what we're dealing with here, that right there was probably a light chop strand layer, just a chop strand reinforcement. And now we have another layer going at a 45 right here. You can see that one there. As we pick through underneath that one, you'll see this layer here running at a 45 this way. So we have a 45 here, we have a 45 here, so there's 2 layers. We know it's a biaxial at a minimum. And then we'll look under that layer, and that's where we have our 0 degree. So we have a 0 degree, a 45, and a 45. So that tells us it's a triaxial mat with what could have been maybe a light chop strand here, or that could have just been a little bit of resin, but I'm going to say that's a light chop strand mat on the back side. So that points us in the right direction. So now we can take that information that we know we have a triaxial mat that is 0.059 inches thick in its final layup, and then we can kind of narrow our choice down from there. So here we are back in the shop. I pulled a couple data sheets out for a couple different laminates. This one's a biaxial. You can see how it's, you know, 2 layers, one going this way, one going this way, and it does have a chop strand mat. And it lays it all out for you here on the architectural data of the laminate. But we know we have a triaxial, and our triaxial has a 45, a 45, and then a 90. So here's a data sheet on a triaxial, and this one has a 45, a 90, and a 45. So it's a little different than the layup that we have. But we went ahead and got our thickness off of this before we burnt it out. So that can help narrow us down a little bit. If we look on our data sheet here, not only do we have the architecture of how it was put together, we have roll weight, we have all this different data, but when we get down here, we have 2 different columns. We have a resin infused column, and then we have an open mold column. Resin infused is for resin infusion, open mold is for more of your, you know, hand layup type of stuff. So it says here for the physical properties, when we're done, our thickness with a fiber content of 69%, which would leave, you know, the rest for resin that we burnt out, that under resin infusion, that final laminate should be a 0.048 in thickness. From looking at where this sample came from, I'm pretty convinced that it was a hand layup. So 0.076 would be our finished thickness. Our sample was 0.059. So we know we're kind of close with this one. It's a heavier mat. Is it the perfect thing to use in this situation? Probably not, but if you don't have any other information, if this is the only information you have, it's better information than just going at it blindly and throwing some laminate that you have off the shelf. Well, there you go, folks. I hope that helped you out with your project. Another tool for you to keep in your toolbox. From our boat shop to yours, have a great day.